All right, let's talk SQL. If you've written any queries, you know the group by is an absolute workhorse. I mean, we use it for everything, but what happens when a really common business question just completely stumps it? Today, we are unlocking a much more powerful tool that's going to fundamentally change how you write queries. We're talking about window functions.
So let's kick things off with a classic request, something you've probably been asked before. Who are the top 2 highest paid employees in each department? Now, on the surface, that sounds pretty simple. You've got the data, you've got the salaries, but that tiny little word each, well, that hides a surprisingly common SQL trap that catches a lot of people off guard.
And it's a trap because the one tool we all instinctively reach for, our go-to for any per-group question, it has this major blind spot. If you try to force a solution with the usual commands, you're either going to go down a rabbit hole of super complex joins or you're just going to get completely stuck.
Okay, so let's work with some simple data here. We've got this employees table. It's got an ID, a name, a department, and a salary. And you can see we've got people spread across HR, finance, and IT, all making different amounts of money. Our goal, remember, is to pull the top 2 earners from each one of these departments.
The second you hear each department, your brain just screams, group by, right? It's the totally logical first instinct. We need to group our employees by their department to figure this out. So let's give it a shot. Let's write a query to find the max salary for each group and just see what happens. And here's what you get. The query runs, no errors. We have the maximum salary for finance, HR, and IT. Perfect. But hang on a second. Who are these people? We've got the what, the top salary, but we've completely lost the who. The employee names are just gone. And this right here shows us the core problem. Group by is all about aggregation. Its entire job is to take a bunch of rows, like all 5 people in the ID department, and just collapse them, smash them down into a single summary row. And in that process, all the details about the individual employees just disappear.
So here's the bottom line. If group by can't even tell us the name of the single top earner, how in the world is it going to give us the top 2? The short answer is, it can't. Not easily anyway. We need a totally different way of thinking about this, one that doesn't destroy our rows.
And this is where the hero of our story comes in, window functions. So here's the big fundamental difference. Group by, like we saw, collapses rows down into a single summary. Poof. But window functions, they do something else entirely. They perform a calculation across a window of related rows, like everyone in the finance department. But then they add that result as a new column to each of the original rows, without losing any of our precious data.
So, the first window function we're going to use to solve our little problem is called row numbering. Its job is super simple. It just assigns a number, 1, 2, 3, 4, to each row within a window that we define. Let's see exactly how it works.
Now, I know the syntax looks a little strange at first, but stick with me. It's actually incredibly logical. You start with the function itself, row number. Then comes the magic part, the over clause. Inside, we say partition by department. That tells SQL to create our windows, or our groups, one for each department. It's kind of like a temporary group by. Then order by salary DSC tells it how to do the numbering inside each of those windows. Highest salary gets number 1, second highest gets 2, and so on.
And this is the result. This right here is the aha moment. Just look at that new row num column. For the finance department, Ravi is number 1, Raj is number 2. But then, as soon as we get to the HR department, the counter resets and Neha gets rank 1. It does the exact same thing for IT. We now have a perfect rank for every single employee within their own department. And crucially, we haven't lost a single row of our original data. This is the power of window functions.
This is awesome. We've got the rank. So the obvious next step is to just add a where clause to our query, right? We can just say, hey, give me everything where the row num is less than or equal to 2. Simple. We should be done.
Well, unfortunately, it's not going to work. And this has to do with SQL's logical order of operations. The database actually processes the where clause before our new row num column is even calculated. So in other words, when the database tries to filter the data, that shiny new column we just created doesn't even exist yet.
So, how do we get around this? We use a really elegant tool called a common table expression, or a CTE. All a CTE does is let you wrap up a query, give it a temporary name, and then you can immediately query it again just as if it were a real table. It's the perfect way to solve our little filtering problem.
So let's look at the final query. It's actually a really simple two-step process. First, using the with keyword, we create our CTE and we give it a name, like ranked employees. You can think of this as just putting our entire window function query into a temporary named box. Then, once that's done, we can write a super simple select statement that pulls from that box and easily filters where row num is less than or equal to 2.
And there it is, the perfect answer to our original question. A clean, simple table showing us exactly the top 2 highest paid employees from each department. No crazy complex joins, no lost data, just a powerful, readable, and elegant query.
So let's just quickly recap the pattern we just unlocked. The real magic of window functions is that they let you do calculations over a group of rows, which you define with partition by, without collapsing them. You tell it how to rank with order by. And then you just wrap the whole thing in a CTE so you can easily filter on your new calculated column. This pattern is your new secret weapon for any top n per group problem you ever face.
And that really brings us to the end. I mean, this is so much more than just finding top salaries, right? You could use this to find the first 3 orders from every new customer, the most recent login for each user on your platform, or a running total of sales month after month. So the real question to leave you with is, now that you have this SQL superpower, what new insights are you going to unlock?